just to be the square root of 2. And the secant of pi, or I'm sorry, the cosecant, sorry about that. So the cosecant of pi over 4, well, that's equal to 1 over y, but so it's also going to be equal to the square root of 2. For the same reason that the secant is equal to the square root of 2. And for the last one, the cotangent of pi over 4, well, that's equal to x over y, but they're both equal, so that's also 1. Okay, so that gives me my 6 trigonometric functions for the case where I'm dealing with a 45-degree angle. Okay, so you might have guessed that next I am going to look at 30, 60, 90-degree angles. Okay, so that basically tells me for 45-degree angle, both my x and y are square root of 2 over 2. Okay? Okay. So how about 30-degree angles and 60-degree angles? So how about 30-degree and 60-degree angles? Now pi is 180, so pi divided by 6 is 30 degrees. And pi divided by 3, or 180 divided by 3, is 60 degrees. Okay? So what we're going to do here is, to figure these out, you might notice that we're using special properties of the unit circle or triangles. So what we have here, let me draw my circle, and I'm not so great at drawing circles. I'm really not. Okay, so that's my kind of circle. All right. So if we want to know, and what we're going to do is we're going to look at 60 degrees over here. Now 60 degrees is the same as pi over 3. And I'm going to notice that if I drop a line straight down here, then this is a 90-degree angle. And since there's 180 degrees in a triangle, this up here is 30 degrees. Okay. So my base of my triangle is going to be my x-coordinate as always, and the height is going to be my y-coordinate, right? Because this height over here is the height on the y-axis, my y-coordinate. This distance here along the x-axis is my x-coordinate, right? So it works out nice like that. Now what I'm going to do is I'm going to play a trick here. And I'm going to just draw this triangle over here where this is 60 degrees. Now this is 30 degrees. Now it's a unit circle, so my radius is 1 here, so this is going to be 1 here. Now this is going to be x, and this is y like before, but I'm going to do a little trick. I'm going to draw the same copy of the triangle over here so that this is 60 degrees. This is 30 degrees. Now this is y, and this is x, and of course these are 90s. Now this is 1 over here, but notice that this is 60 degrees, 30 and 30 gives me 60, so it's a 60, 60, 60 equilateral triangle. So that means that all the sides are equal. So this side is 1, this side is 1, this side is 1. But this is also 2x. So that tells me that 2x is also equal to 1, or x is equal to 1/2. All right. Now, how do I find the y-coordinate? Well, I'm on the unit circle, or if you know Pythagorean's theorem, it's the same thing. Well, I know that x squared plus y squared is equal to 1. But x is equal to 1/2, so I know 1/2 squared plus y squared is equal to 1, which is the same as 1/4 plus y squared is equal to 1. I'm running out of room here. Subtract 1/4 from both sides, and y squared is equal to 3 over 4. Well, if y squared is equal to 3 over 4, then y is equal to the square root of 3 over 4, which is equal to the square root of 3 divided by 2. So I know that if I have a 60-degree angle, so for 60 degrees, or pi over 3, I know that my x-coordinate is 1/2, and my y-coordinate is square root of 3 over 2. And that's x comma y, right? Now, if I flip the triangle around, I'll notice I get 30 degrees, because this is 30 right here, so the x and y just switch places. So for 30 degrees, or pi over 6, my x-coordinate is going to be square root of 3 over 2, and my y-coordinate is going to be 1/2. Okay, so they just flip. So we can go on to another sheet of paper, and we can define our trigonometric functions for 30 and 60 degrees. So I'm going to do it in terms of radians. So first we're going to do the sine. Okay, so I'll just note first that we're working with pi over 3, which is 60 degrees. And I'm going to have my x is equal to 1/2. And y is going to be equal to the square root of 3 divided by 2. Right? So the sine of pi over 3 is going to be equal to the square root of 3 divided by 2. The cosine of pi divided by 3 is going to also be equal to the square, is going to be equal to my x-coordinate, which is 1/2. The tangent of pi over 3 is going to be y divided by x. So that's equal to the square root of 3 divided by 2 divided by 1/2. Well, if I multiply the numerator and denominator by 2, this is just going the 2 is going to cancel with the 1/2, and the 2 is going to cancel on top. Is just going to leave me with the square root of 3. The cotangent of pi over 3 is going to be x over y, which is just the reciprocal of this, which is just equal to, so it's just going to be 1 over the square root of 3, which is equal to the square root of 3 over 3. Okay? And we're going to notice that the secant of pi over 3 is going to be equal to, well, that's going to be equal to 1 over x. So this is going to be equal to 1 over 1/2, which is 2, and the cosecant of pi over 3 is going to be equal to 1 over y. So this is going to be equal to 2 divided by the square root of 3, which is going to be equal to 2 square root of 3 all over 3. Okay, and you can do the same thing for 30 degrees or pi over 6. But if you like, you can look the table up in your book. It's once you have x and y, and again for the 30 degrees, it's just going to be flipped. Actually, you can write down. Well, I won't. For the 30 degrees, it's going to be flipped because the x value is going to be square root of 3 over 2. The y value is going to 1/2. You can derive these in the exact same way. And again, you can take a look at your textbook for that. Okay. Okay. So what we're going to want to do now is we're going to look at, say, if we have, say, multiples of pi over 4. We're going to look at multiples and negatives for pi over 4, pi over 6, and pi over 3. Pi over 4, pi divided by 6, and pi divided by 3. And again, that's 45, 30, and 60 degrees. And we're also going to look at negatives. So we're looking at multiples and negatives. And you can think of a negative as a multiple, the angle times -1. So multiples and negatives. All right. So the first one, we're going to look at an example, is we're going to want to find the sine. Say we're going to want to find the sine of 135 degrees. Okay? And I'm going to do some of the examples in degrees, some of the examples in terms of radians. So the first thing we're going to want to do is, the first step, we're going to want to identify what quadrant we're in. Okay, identify the quadrant. And so this is 0 degrees. This is 90 degrees. This is 180 degrees. So 180 degrees is bigger than 135. So we've identified the quadrant. We're in the second quadrant. So we started at 0 degrees. And we came around and we stopped here. Here's our terminal side. And just pretend this is my unit circle here. Good unit circle, right? Okay. So we found this is, so this angle over here is 135 degrees. Sorry for that picture. And we stopped over here going to 135 degrees. Now the next thing is we're going to want to find the angle the terminal side makes with the nearest x-axis. So we're going to want to find the angle, and we're going to call this a reference angle. Find the angle. I really apologize for that picture. If I had erasers, I'd redraw it. So find the angle the terminal side